Okay, so this time we will do this question, a diameter of a binary tree. So it is an easy level question, and let's see what is written here. Given the root of binary tree, written the length of diameter of tree. So what is the diameter? First you need to know. Diameter of a binary tree is the length of longest path between two nodes, any two nodes in the tree. Okay, and this path may pass from root or through root or not. So see this. I have this example for you. Diameter of this tree is what? 3. If you see that example, diameter of this tree is 3. How? First path is this. See this pink color path. Okay, for 4, 2, 1, 3. Yes. So 1. If you see now, you would be saying there are 4 nodes, but our answer is 3 only. Why? Because see these path 1, 2, and 3. These are the only path. If you see this yellow color line, these are also 4 nodes, but path is only 1, 2, 3. These are 3 path only. So you can take any of them. 5 to 1, 3 is also a path, and 4 to 1. But path length is 3 only. So you have to take maximum path length. If you see that example is not sufficient for to understand this question properly. That's why I have taken this example. So you see this question again. Your diameter, any two nodes, between any two nodes. Okay. So uh, if you see this diameter, what will be the diameter here? See this seventh node. Okay, okay, then 1, 2, 3, 4, 5. This 7 to 3. Okay, I have not circled it properly. This 7 to, okay, don't mind, but it is like this only. So if you see this 7 to 3 path, 1, 2, 3, 4. This is my maximum diameter. If you take this 5, that then length will be 1, 2, 3 only. That's why this cannot be our diameter. And see, that's why our diameter will be 4 here. And if you take that, see, our diameter may or may not, this line means diameter may pass from root through root or not. That means this only. Here our diameter is not passing through root. It is this, this, and this, and this. Okay. So my drawing is really bad, but drawing it with mouse is really a tough job. That's why it is happening. So see, now you cannot include this root. Why? If you include that root, your left dot length is this. See, what is the formula here? See, if you see this note second, okay, left depth is 1 and right depth is 1, 2, 3. So 3. And if you add both of them, you will get 4. 1 plus 3 is 4. If you see here, left depth is 2 and right depth is 3 only, so means 1. If you add them, this is the formula. Very easy formula. Okay. But if you see this left node, this one node, left depth is what? Left depth is your 1, 2, 3, 4. 4. But right depth, see, your diameter should be from one node to another, but right, it is no node in right of it. That's why this will not include our root. Yes, no node existing in right. That's why. So that is our that our solution will be. Let's see how we'll calculate it. So I'm clearing this up. Okay. So now let's do it. That's the way. So we will go to bottom first. We will go to bottom first, and then our bottom. See, our bottom will always be included in diameter. Yes, we'll go to left bottom and right bottom first. So how to go? Let function. I'm using a function not like this function. Function reverse. Yes, and inside it current value is there. Yes. So I'll call a function here, and then at last node I will check left depth. That is null. So left depth is 0. Yes. And see, whenever first time I will get this depth, our answer will be that only. So left depth is 0. Yes. And our right depth is what? Right depth is 0 only. Again null. So left and right are 0 only. So its depth will be 1. Its depth will be 1. Traverse. Okay, traverse 1. Traverse 1. We will store this maximum somewhere. We will store this maximum somewhere. We can use top down approach or bottom approach, any of them, but I will use a bottom up approach here. I will call this function with current dot left, and then I will call this function traverse with current dot right. Yes, very easy. And let left is equals to this, and let right is equals to this only. Traverse current dot right. So left will be this and right will be this. So this will give me return me length. Okay, I'll add both. See, if you see this 3 node, its left length is 0 and right length is also 0. So, and its length is 1 only. Like, see, I'll add both of them. Okay, and I'll store it somewhere. Let this variable be max. Okay, I'll store it somewhere. So whenever I go to left, I will store it somewhere. Uh, how can I store that? I will call, if this function will be called for null. If suppose if this function is called for null, not of current, then this will return me 0 only. Yes, this will return me 0. So both of them, add this 3 node, both of them will return me 0. Suppose I'm this 4 node, both of them will return me 0. I'll add both of them. Uh, Left plus right. Okay, and I'm storing it somewhere. Let what should I shall I name that variable? That variable is a dia. Okay, diameter, so take dia only. So let left plus right is dia. Okay, or current diameter, current uh, dia. Okay, current diameter is left plus right only, and I will store it somewhere also. Let max diameter is equals to initially 0. Yes, 0. So what will be the max in both of them? I will store in that only. So max dia is equals to current dia, and okay, not like this. Math dot max current diameter comma max dia. In both of them, which will be the max, that will be only a diameter. So max dia. Okay. So again, this is our max dia, and max dia will be stored in this diameter variable, and then I will return what? Return. Uh, I will return its depth. Its depth is what? Which one is maximum in them? Math dot max. Which one is maximum in them? Left comma right. Either of them. Which one is maximum? Plus one. Yes, not 12. Plus one only. So it will return its depth. Then if I now call this traverse function with my root, and I'm returning this what? Max diameter. So what will I get? Let me see. I should get my answer now. uh, Even I don't. Yes, see, this is accepted, and if I submit this code, this will also be run. This will run completely fine. Let me see, loading, and any wrong okay, so see, our solution is accepted. So that question was very easy. You just have to return depth. See, your last node will also always be maximum diameter. Okay, then increasing. I'm using a bottom approach. First we'll go to this left, we'll return 0 from it, its depth will be 1. Then that's how we'll calculate this. And if I tell you this example, if you write this example as a test case here, that will also give you the right answer. Okay, so thank you so much. That was my solution for this question, and very easy question again. That's why it is written easy there. So thank you so much, and have a nice day.